All right, everybody. Let's see. Today in sixth period, we didn't get through the entire lesson, so I definitely wanted to make this copy for them. I'm going to show you guys how to turn repeating decimals into fractions. We've done this lesson a little bit in class, so I may skip a couple of things, but I definitely want to put it up online so you could check it out and see it at your leisure. So today we want to find out how to turn a repeating decimal such as 444444444 forever into a fraction. Well, there are a couple of steps. First of all, I don't know what the fraction is, so what I like to do is just say that I don't know what the fraction is, and the number we use for a fraction we don't know is x. So x is equals 0.4 repeating. How do I solve this? First step, I'm going to multiply both sides by 10. The reason I'm going to do that is when I multiply this side by 10, I get 10x. That's easy. But when I multiply this side by 10, I end up getting 4.4 repeating. Because when you multiply by 10, it slides the decimal one spot to the right. The next step is to subtract the original number. That was the x and the 4 repeating. What you're going to notice is when you subtract, one side is easy, that gets you 9x, and the other side turns out to be a very nice number of just 4. Because all these 4's into infinity will be subtracted from each other and they will always equal 0. Once you get to this point, now it's just one-step algebra, and you divide by 9 and divide by 9. And therefore, the fraction that gets us 0.4444444 repeating forever is 4/9. If you like, use a calculator to check to see if that's right. So here's another one for you to try. Once again, I don't know what the fraction is, so x equals 0.5 repeating because I don't know what the fraction is going to be. What I do then is I multiply both sides by 10. That allows me to slide the decimal one spot, and when I subtract the x, all these 5's end up becoming 0. And I'm left with simply 5.0. Now 9x equals 5, and it's one-step algebra. Divide by 9 and divide by 9, and x equals 5/9. If you have questions about this, don't be afraid to go to page 316 in the book and double-check the example in the book. They also have the steps written for you there as well. All right, the next one we came up with was this one. 0.25 repeating. So this is really 0.25, 25, 25, 25, 25, 25. So that means that the fraction we don't know is 0.25 repeating. What I need to do here is multiply both sides by 100. Why 100? Because I don't want to move the decimal just one spot. I want to move the decimal 2 spots. And I do that by multiplying it by 100. Because 0.25 repeating multiplied by 100 gets me 25.25 repeating. Now I end up with a little bit larger number here with the 100x, but that's okay. I subtract the original number just like in the other one, and notice all these 0.25's are going to turn into 0. So I end up with 99x equals 25.00, or 99x equals 25. Okay, from here, I just divide by 99 and divide by 99. And I get my answer. Check it out in the calculator. If you do 25 divided by 99, it will be 25, 25, 25, 25, 25. It works. So here's one for you guys to try. All right, I'm back. So once again, I didn't know what the fraction was, so x equals 0.18 repeating. I want to move the decimal 2 spots, therefore I multiply by 100. That gets me 100x equals 18.18 repeating, and I subtract the x and subtract the 0.18 repeating. That gets me 99x equals 18.00, and 99x equals 18. Now when I divide by 99 and divide by 99, I get my answer. However, don't forget to simplify, because it'll be 2/11. Once again, plug in 2/11, or 2 divided by 11 into a calculator, you'll get 18, 18, 18, 18, 18, 18. All right, lastly, here we go. What if I have this one? I have 2 numbers behind the decimal, however, I only have 1 number being repeated. So, the rule is you always multiply by the number of zeros as the number of numbers underneath the repeating symbol. So since I only have 1 number being repeated, I only have to multiply both sides by 10. In the other situation, I had two numbers underneath the repeating sign. That's why I had to multiply by 100 so I could move it twice. So if I multiply by 10, I end up getting 2.33 repeating because notice, I slide the decimal only one spot. When I subtract the original amount, check it out. All these three repeatings will turn to 0, and I just have to subtract this. 3 minus 2 is 1, and 2 minus nothing is 2. And all these became 0. Now when I divide by 9, I get a decimal as my numerator. No decimals allowed in the numerator. So the trick is to multiply by 10 on the top and the bottom, and you get 21 over 90. Can you simplify it? Yes. Divide by 3 and divide by 3, and you get 7/30. If you're wondering about this problem, it is in the book, example number 2 on page 317. So feel free to take a look at it. And then try this one. All right, I'm back. Notice one number is underneath the repeating symbol, so I multiply both sides by 10. That moves the decimal one spot over, so I get 5.4 for repeating. When I subtract x and subtract the original one, 0.54 repeating, then I end up getting 9x equals 0.490. Notice that all the 4's ended up becoming 0. Divide by 9 and divide by 9. Multiply by 10, multiply by 10. Now there's no decimal in the denominator, in the numerator, and I can't simplify it, so you're done. All right, everyone, that's the lesson. If you got questions, bring them to me on Monday. I'll see you guys soon. Take care.